All right, so now we're going to do the properties of logarithms. And these are actually exponent rules, okay? But it just may not seem that way. So I'll kind of sort of remind you as we go along. First of all, you already know a couple of these. If I have a log, I don't care what the base is, so I'm going to put a base of b. It could be e, it could be 10, it could be 35, I don't care. Whatever the base is. If your argument is 1, your answer is 0 immediately. Okay? Another property is going to be if your base and your argument match, your answer is 1. If your base and your argument match, your answer is 1. So if this was log 5 of 5, it would be 1. Why is that? Because 5 raised to the first power would give you 5. Okay? Another one is if you are multiplying. So let's do log base b of xy. So I have an x times a y. I can separate that out into 2 separate logs. So I can rewrite that as log base b of x plus log base b of y. Okay? Now if you think about this, the reason you can do that is because if you are multiplying exponentials with the same base, so if I have log base, I don't care what my base is, base 7 and base 8, or sorry, base to the 7th, base to the 8th. You're multiplying, but what do you do to your exponents? You add them, okay? So this represents an exponent, and this represents an exponent, and they're in the same base, so you add them together, okay? So your answer here would be b to the 17th, or sorry, 15th, because I know how to add, okay, 15th. And then, but that's why you're doing what you're doing. All right, so if multiplication results in addition, guess what division results in? So if I've got a single log and I want to expand it, I want to make it as messy as possible, okay? I'm going to notice that I've got division on the inside. It'll be subtraction on the outside. So that'll be log base of x minus log base of y. And I'm saying base, just whatever the base is, I don't care. And in order to understand this, let's do this one for a second. We're going to practice. I have log base of x times x. Okay, so what does that mean? That means I actually have log base x plus log base x. Well, how many log base x's do I have? I have 2 log base x's. Okay, so how could I have written this to start with? I could have said log base of x squared. So if you've got an exponent attached to your argument, you can drop him out front as a coefficient. Okay, so this 2 drops out front as a coefficient. So this is how we expand them. Well, now I can work backwards and I can condense. So if I've got multiple logs being added together, I can condense them using multiplication. Okay, if I've got multiple logs being subtracted, I can condense using division. And that this is just kind of sort of the same thing. So that is what we're going to be doing. The only other thing is the change of base formula. What happens if you're working with 2 different bases? So if I've got 2 different bases, and I want to make them work in the same base, I don't even know what I'm saying. All right, I want to change my base because my calculator doesn't know it. Your calculator knows 2 bases. Your calculator knows base e, which is the natural log, and base 10, which is the common log. It doesn't know base 2. It doesn't know base 17. It doesn't know any of that stuff. So we have to trick it. Okay, so for instance, let's go back to what we did like 14 million videos ago. If I have 2 raised to some magical power is 6.124, okay? Let's change that back into logarithmic notation. So what is my base? My base is 2. What is the answer? The answer is the argument, and it equals the exponent. Well, this would be all fine, great, and wonderful if I could put this in my calculator. My calculator doesn't know base 2. So I got to figure out how to go from here. So the way that you trick it it's called the change of base formula, is I'm going to take the log of the argument, so the log of 6.124 over the log of the base that my calculator doesn't know. So the log of 2. Now notice I changed it into base 10. Okay? So my calculator does know base 10. So you could also, it's just a button change, say 6.124 and natural log of 2. As long as you're using base 10 on top and bottom, or base E on top and bottom, I don't care. So the question is, what is the answer? So if I use the log of 6.124 divided by the log of 2, I get 2.61447, whatever. Okay, and that should make sense because I'm looking for an exponent between 2 and 3. Okay, on this one, if I poke natural log, 6.124 divided by natural log of 2, well, what do I get? I get the exact same answer. So I don't care if you poke the common log button or if you poke the natural log button, as long as you poke them consistently. So don't put one of them on top and one of them on bottom. That'll mess everything up. All right, so we're going to practice. We're going to see if we can get through this thing in one fell swoop. Here we go. So I want to expand the following. So I have an 81 times an x to the 8th. So I've got two separate logs. So I have log 9 of 81 plus log 9 of x to the 8th. And now I want to see if I can do anything else. If you can change this into a pretty number, you need to do so. So the question is, do I know 9 raised to what power will give me an 81? Well, 9 raised to the second power will give me an 81. So that's going to go away, and that's going to become a 2. Okay? So log 9 of 81 is the exact same thing as a 2. On this one, the only other thing I can do is drop that exponent out front. So I have equals 8 log 9 of x. So you have expanded. Another thing to remember, if you're expanding, you don't want to see any exponents. So if you're expanding, exponents are a no-no. But your answer here is going to be 2 plus log 9, oops, sorry, I forgot my 8, x. Okay? So 2 plus 8 log 9 of x. All right, so this one, this is joined by addition. I can only expand if it's joined by multiplication or division. So how am I going to handle this one? Well, let's factor it. So what's a number that goes into 10 and 15? I can pull out a 5. So that's log 5 of 5. And now I have, not a 5, I have a 2x plus 3y. Okay? So now I have two things joined by multiplication, so now I can separate it out. So that gives me log 5 of 5 plus log 5 of 2x plus 3y. Okay, so is there anything else I can do? This one, I can't factor it down any further, so I'm done. This one, is there a number or a power I can raise 5 to get 5 for an answer? Well, 5 to the first is 5. So remember, if your base and your argument match, that's just a really weird way to write a 1. So your answer is 1 plus log 5 of 2x plus 3y. Okay? This one, holy cow. All right, so we're going to have to dive deep. Life would be grand, except for I see that there is a variable in my exponent, and I'm kind of at a loss, and so I'm going to work from the inside out. If you don't know what to do, do something you know how to do. Well, order of operations says to work from the inside out. So second of all, what base am I in? It's not written, but it says log, so I'm in base 10. So I'm going to cover this up for a second. Can I rewrite this as a power of 10? That says 10,000. So that's the same thing as 10 to the 4th. So this becomes 10 to the 4th raised to the 25x. Well, what do you do if you have a power raised to a power? You multiply. So that becomes 10 to the 100x. Okay? So right now I have 10 to the 100x. And I'm going to scoot out a little bit because now I'm stuck. And I notice that I have a log. All right, so log. Well, what's something I know how to do? Well, if I am trying to expand and simplify as much as possible, if I've got an exponent, I can drop it out front. So I'm going to drop that exponent out front. And now I notice something. My base, which is 10, I'm too lazy to write it, and my argument match. So this turns into a 1. So he's gone. So this whole thing, all over here, just simplified down to 100x. So now I'm stuck again. So move out again, and now I've got a log. So really this says log of 100x. Okay, what do I have? Multiplication. I got two things being multiplied together, so separate them out. So log 100 plus log x. Each factor gets his own log. Okay. Now, can I rewrite this one? Remember, your base is 10. If you can rewrite it to a pretty number, you need to. So 10 raised to some power is 100. What do you do to a 10 to get 100? You square it. So this becomes a 2. Okay, so I have 2 plus log x. Okay. This one, we are going to expand as much as possible. So I want multiple logarithms. Well, I need to factor. Okay, because this is all joined by addition, and it needs to either be joined by multiplication or division if I'm going to do this. So I'm going to factor out a 2 first, and then go from there. So that gives me x squared plus 8x plus 16. And then can I factor this again? Well, two numbers that multiply to 16 that add up to 8 are 4 and 4. So I get log 2 of 2. X plus 4 times x plus 4 is x plus 4 squared. So now I have this thing times this thing, and I'm going to separate it out to two separate logs. So I've got log 2 of 2 plus log 2 of x plus 4 squared. And now to see if you can make it pretty. 2 raised to what power is 2? Your base and your argument match. This turns into a 1. And then what's the only thing? If I'm expanding, exponents are a no-no. So drop that exponent out front. So he is plus 2 log 2 of x plus 4. Okay? So that is your answer on that one. All right, so now we're going to condense. I can do one of these. All right, so if I'm going to condense, I have multiple logs. The first thing you want to do if you are condensing, which starts with a C sound, or a K sound, whatever, is you want to kick up your coefficients if you have any. Okay? He has a coefficient of 1, I don't care. He has a coefficient of 6, so I'm going to kick him up. And he's going to become an exponent. He has a coefficient of 4, I'm going to kick him up, he's going to become an exponent. And now everything is the same. All your bases are e, so just leave it as a single natural log. And now, how is this joined? It's joined by addition. So on the inside, if it's addition on the outside, it's multiplication on the inside. So I have a 4x to the 6th on the inside. How is this joined? It's joined by division. It's subtraction on the outside, so it's division on the inside. So he's a y to the 4th. And now you have squished it, or you've condensed it as much as possible. Okay, you can't go any further. All right, so we're going to stop there.